Good morning to one and all. I'm Kirti from BVRIT Narsapur. My topic is design of register. First, we'll see what is a register. Register is nothing but a data storage device. What is a data? Data is nothing but a binary information that is zeros and ones. So overall, a register is a group of binary cells which is suitable for holding a binary information. If we consider some n-bit register, that n-bit register consists of a group of n flip-flops. Those flip-flops are used to capable of storing n bits of binary information. First, we'll see why we need to store a data. Whatever the data we are storing, that will be protected and it can be reused whenever we need it. And the data which is stored, that can be transferred within the registers, that will be calling it as a shift register. We'll see the types of shift registers. The first register is a serial in serial out shift register. Next is serial in parallel out shift register, parallel in serial out shift register, parallel in parallel out shift register, and the final one is universal shift register. So we'll see how these shift registers and operations. So serial in, serial out shift register. That means the data will be stored serially and the data will be collected at the output side serially. In serial in parallel out shift register, the data will be stored serially and the data will be collected parallelly. In parallel in serial out shift register, the data will be stored parallelly and the data will be collected serially. In parallel out shift register, the data will be stored parallelly and we'll be collecting the data parallelly. So now we'll see the block of parallel in parallel out. So here is the block of parallel in parallel out shift register. We have considered some 4-bit. So parallel inputs, parallel outputs. We are having clock and enable. When these are high, then the shifting process will start. Left shift or right shift. Now we'll see one of the internal process how the shifting operation is done. So we'll go with serial and serial out shift register. For example, I'm taking a data of 100 01111 8-bit data. So I'm having the flip-flop 0 to 7 as it is an 8-bit data. So for the first clock cycle or passage clock, this first data will be stored in the first flip-flop, and for the next clock cycle, this second data will be stored in the first flip-flop and this one will be transferred to the next flip-flop. And for the next clock cycle, again the process repeat. The third data will be stored in the first flip-flop and these will be transferred to the next flip-flop. That is right shift operation. And again for the next clock cycle, it will be repeated. Finally, for every clock pulse, it will set and it will stored into the first flip-flop, and then this process continues. Finally, we will get the data as 100 01111. So now we'll be seeing about universal shift register. So this is the universal shift register. Universal shift register is nothing but a combination of unidirectional and bidirectional shift register with a parallel load. So this is the truth table of a universal shift register. When both our inputs are low, then there won't be any change. When both inputs are 0 and 1, then there will be a shift right operation, that is a right shift operation. When it is 1 0, there will be a left shift operation. When both are ones, there will be a parallel loop. So we'll see the operation of it. So we are having registers. Whenever we are having the registers, that will be a data transmission either from right to left or left to right. So this will be calling it as a bidirectional, and we are having some parallel inputs. So bidirectional and parallel inputs all together we will be calling it as a universal shift register. So there's a 4-bit universal shift register. We are having muxes, that is 4:1 mux, 4 inputs and 1 output with 2 selection lines. So we'll see the operation of mux. So when it is 0 0, this first selection line will be selected and this will be given to the output. Here the output will be stored in this flip-flop, and we will be getting the output. And next for 0 and 1, this will be selected and will be getting the output, and 1 0, this one will be selected and will be getting the output. For 1 1, the last one will be selected and will be getting the output. For example, if we want to store a data of 1011, so now how the process, according to our truth table, if we select 0 0, there won't be any change in the operation. So I am taking 0 0 condition and my data is 1011. So there shouldn't be any change in the output. So we'll be seeing. So this is our stored, we want to store a data, that is one. So this one, it is going in this way. So the first one will be selected for 0 0, that is 1. So this one will be going to the output, and now this one will be stored here, that is 1. That means the previously our output is 1 which we want to store, and here also we got 1. So there is no change in the operation for 0 0. In the same way for these things too. Now we'll go with 0 and 1. If we go with 0 and 1, then there will be a right shift operation. So if we go with 0 and 1, this one pin will be selected. So this is nothing but the shift operator, right shift operation. So this one will be given to the output and it will be stored here. Now this output again, it will go for the next mux, that is here. That is here, and this will be go to the output and it will be stored here. So we'll be getting again 1. So that means this one is shifted to here. So right shift operation. Similarly, if we go with 1 and 0, then there will be a left shift operation. So this is the left shift operation. So this one will be selected. This will be given to the output. So it will be stored here, that one. And again this one, from here again, it will go to the next mux for the second thing. So it will be going, the output, it will be stored here. So the same thing will be shifted to here. So this is the left shifting. If we go with 1 and 1, then it will be a parallel loop. So 1 and 1 means this I4, I3, I2, I1. So parallelly it will go to the outputs and it will be stored to the respective D flip-flops, and we will be getting the outputs as A4, A3, A2, A1. So this is about all overall universal shift register and registers. To make these things understand to the students, we can plan activities like mind mapping and think pair share. Thank you.